Okay, for time 0 to 12, when is the particle moving left? Said 0 to 12, particle moves along the x-axis. I don't need that. We talk all the time about that. Velocity of the particle, so pretty straightforward problem. They give me the velocity. You want to know when the particle is moving left. They do also tell me that the position at time 0 is -2. I'll need that at some point probably. Okay, I know the particle is moving left whenever the velocity is negative. With a calculator, really easy. Without a calculator, a little bit harder. But I know that if I write down v of t is equal to 0 when, and now I've got to go find the times, this statement right here will often get me 1 point. So I'm going to write that for sure to try and get that point, which often is given. And checking the scoring guide here, looks wrong way, sorry. Sure enough, because I wrote down that I wanted to see when v of t was equaling 0, they give me 1 point. So now I've got to figure out when v of t is actually negative is what I really care about. But I can't find out when v of t is negative because I don't have a graph. I have to do a sign chart. So to do a sign chart of v of t, I do have to find out when v of t is 0. So that all worked out nicely. I want to always write that down. Try and get that point. So I'm interested from time 0, these are times, to time 12, when the velocity is negative. And I start out by trying to find out when the velocity is 0. That means I've got to figure out when the cosine of pi over 6 t has a value of 0. It means I've got to find the right time to make all of this 0. Well, unit circle, cosine is the across. So right here at an angle of pi over 2, or 3 pi over 2, is where the cosine is equal to 0. So I've got this formula, cosine pi over 6t. I need that to be 0, which means I need this thing inside to equal pi over 2. Well, if you put a 3 in for the t, you'll have 3 pi over 6, which is the same thing as pi over 2. So I just discovered that one of the times here is time equal 3. That's a time when the velocity will be 0. I'll write it out one more time. Because the cosine of pi over 6 multiplied by a time of 3 would give you the cosine of 3 pi over 6, which is the same thing as the cosine of pi over 2. And that is equal to 0. So yes, I know now that when time is equal to 3, the velocity has a value of 0. Using that exact same idea, I note that I also would like the pi over 6 times time to equal 3 pi over 2. Well, 3 halves, same thing as 9/6. So that means I want my time to be 9. So the other time is right here at 9. Okay, so the way this thing was scored is I got 1 point for just telling the grader I'm going to go look for when velocity is 0. Have to do that so I can get a sign chart of velocity. Then I've got to figure out the interval. So this work here is what I just showed you. Now I have to do a sign chart. to finish the process. So, got 0 and 12, those are times. We've got 3 and 9, those are also times. We've got to test the velocity at the times that are in between the times when the velocity is 0. So I choose 6. Because that's pretty easy. The velocity at time 6 will equal cosine of pi over 6 multiplied by 6, which would equal cosine of 6 pi over 6, which would simply be the cosine of pi. On the unit circle, pi is right here. Cosine means we're going across, so we'd be going to the left. Going to the left by 1 means the value down here is definitely -1. So that means over here on my sign chart, for all of these times, the velocity will be negative. That's when the particle's moving left. Better make sure that the other time periods are okay. So I'm going to try the velocity at time 12. That'll equal cosine. You don't have to write any of this. You can do it in your head. I'm writing it out so no one gets lost, hopefully. So this is cosine of 2 pi. 12 divided by 6 is 2. An angle of 2 pi is right here. So because cosine is the across, I would be going across to the right by 1. That's a +1. Hence, all these are positive. Last one to check is the cosine of time equals 0. So the cosine of time equals 0 here, the velocity at time 0. This would be the velocity at time 0. That's going to equal the cosine of 0. On the unit circle, angle 0 is right here again. That's going over to the right by 1. So these are all positive. That's how I wrote down that from time 3 to time 9, not including, don't put the equal sign. At the equal sign, the velocity is 0. The particle is not moving left. The particle is only moving left between 3 and 9, but not including 3 and 9. That gets you point number 2 on this problem. Point number 2.